So chapter 5 of pre-calculus is similar to chapter 13 of algebra 2. Now chapter 13 of algebra 2 we didn't reach that far. We did cover chapter 12, the trigonometric functions, which that is equivalent to pre-calculus chapter 4. So chapter 5 pre-calculus is new. It deals with trigonometric identities and solving trigonometric equations. In first lesson, trigonometric identities, we are learning about, or relearning about some of these identities which we have already encountered in algebra 2. There are 4 types of identities introduced in lesson 5.1. The reciprocal and quotient identities, the Pythagorean identities, we have the cofunction identities, and the odd-even identities. So this is an introduction that will apply to all the exercises of lesson 5-1. There are 8 trigonometric identities. 6 of them are, so there are 8 of the reciprocal and quotient identities. 6 of them are reciprocal identities, and 2 of them are just the quotient identities. The quotient identities are related to, they're listed at the bottom here. Tangent theta is equal to sine theta over cosine theta, and cotangent theta is the reciprocal of tangent theta, which means is equal to cosine theta over sine theta. So reciprocal identities. Sine is the reciprocal of cosecant. Sine theta is 1 over cosecant theta. Cosecant is the reciprocal of secant theta. Tangent theta is the reciprocal of cotangent theta. And similarly, cosecant is the reciprocal of 1, it's the reciprocal of sine theta, 1 over sine theta. And secant theta, 1 over cosine theta. Cotangent theta is 1 over tangent theta. Now, the Pythagorean identity, it's very useful. It's what it's in this box here. It's sine square theta plus cosine square theta is equal to 1, and comes from, can be proven by using the unit circle, where we draw an angle theta. In the unit circle, the radius is equal to 1, and in this triangle, where the radius is equal to 1, the angle theta is marked. The side opposite angle theta, I'm marking it y, and the side adjacent to angle theta, I'm marking it x. By definition, sine theta is equal to opposite over adjacent, and opposite over hypotenuse. Since the hypotenuse is equal to 1, because that's equal to the radius on the unit circle, that means that the sine theta is the same, has the same value as the size of the opposite side in that right triangle, which that opposite side is marked y. Similarly, cosine theta is by definition is adjacent over hypotenuse. Adjacent is the x side, and the hypotenuse is equal to 1, which means cosine theta is adjacent over 1, or simply adjacent, and that means has the value of x, the length of that horizontal segment, that horizontal leg of the right triangle. So by using Pythagoras theorem, which in that triangle says that the sum of the squares of the legs is equal to the square of the hypotenuse. There's a shorter leg and there's a longer leg. The shorter leg is the vertical y, the longer leg is the horizontal x. So the shorter leg x squared, the shorter leg y squared plus the longer leg x squared is equal to hypotenuse squared or 1 squared. Now simplify y with sine theta and x with cosine theta, substitute, and you end up with sine squared theta plus cosine squared theta is equal to 1. This is Pythagorean identity for trigonometry. If we take this Pythagorean identity and we first divide it by sine squared theta, we end up with another Pythagorean identity, which is at the bottom now. 1 plus cotangent square theta is equal to cosecant square theta. How do we get to that? We said we divide the Pythagorean identity both sides of the equal sign by sine square theta. So on the left side I have sine square theta plus cosine square theta divided by sine square theta. On the right side is 1 divided by sine square theta. And break the fraction on the left side in two separate fractions. So there will be sine square theta over sine square theta plus cosine square theta over sine square theta is equal to 1 over sine square theta. Obviously sine square theta divided by sine square theta, that's equal to 1. By definition, cotangent is equal to cosine theta divided by sine theta, which means cosine square theta divided by sine square theta, there will be cotangent square theta. And 1 over sine square theta, that's the same as cosecant theta. Now, this is the second form of the Pythagorean identity. Form 1, form 2, and there's a form 3 that results from dividing the Pythagorean identity by cosine square theta. And that means that leads to the final form, tangent square theta plus 1 is equal to secant square theta.